and welcome to another JavaScript Exchange, our fifth event since the start back in February. As usual, I'll just do a quick intro and then we will start with the talks. So as you may or may not know, JavaScript Exchange is part of a much wider events group, which is known as Docs, which includes the DevOps Exchange as well. As you can see there, spread up and down the country and into Europe. So hopefully JavaScript Exchange, obviously going from strength to strength, increasing members, we can replicate that success. In order to stay in touch with us, of course, you would have joined us via our meetup page where we release all the latest details on talks and events. We're also active on Twitter with our handle there, JavaScript_EX, and of course on LinkedIn, JavaScript Exchange. So for the event this evening, we'll be running 3 talks as usual, and there'll be a Q&A function which will be active throughout all of the talks. It's very easy to use. All you need to do is hit Q&A at the bottom of your screen, which is within your Zoom window, and you can ask any questions to any of the panelists throughout the duration of the talks. They'll also have visibility of that right up until the end, so they'll be able to type away answers if we do, for whatever reason, need to move on or run out of time, them explaining it after their talks. So this evening we've got 3 talks lined up for you. Firstly, we'll be kicking off with Iman over at Pento. He'll be running us through finding a home for Node.js and a polyglot architecture. Then we'll be moving to Dani over at Busuu. He'll be talking about astronomical data analysis using NASA's API to explore some interesting exoplanets using Threejs. And then finally, Srushtika over at Ably Realtime will be finishing up with a talk on building a real-time multiplayer browser game with Phaser 3 and Ably.
Thanks, Tom. Just a bit of background. So our events are sponsored by Linux Recruit. And so a big thank you to these guys. Without them, we wouldn't be able to have the time to plan the events or the speakers. And hopefully when we can get back to it, the venues as well. Both myself and Tom, we both work within the software development team here at Linux Recruit. So if you are looking to maybe see what else is in the market or you're looking to grow your team, feel free to get in touch with us. Our contact details are there. Another thing, we are always on the lookout for new speakers. So if you do fancy having a go, feel free to drop us an email at info@linuxrecruit.co.uk. And next week, we also have our next event, which is going to be an exciting one. We have joined forces with Vicario. So it's going to be more of an interactive online coding challenge. So expect it to be pretty fun. We're launching details in our meetup group tomorrow. So keep an eye out. And without further ado, I'm going to pass you on to Iman, who is our first speaker from Pento. Take it away, Iman.
All right. So let me just share my screen. Okay. So yeah. Hi everyone. I'd just like to thank Tom, of course, first for inviting me to give this talk. I really appreciate it, and of course, to the rest of the JavaScript Exchange team for having the event in the first place. A little bit about me. As you know, my name's Iman, and my journey kind of started with startups right out of college. So we set up this startup called Co&Co in Edinburgh, and that went on for almost 2 years. In between that, I worked at Accenture for a year in the DevOps department specifically. And now, since the start of this year, I've been a full stack engineer at Pento, loving it. And what we do is kind of automate payroll for small to medium businesses. Initially, it was in the DK market only, but now we've expanded to the UK. But we'll get more into that a bit later. So kind of through these experiences, I've sort of had an early, how would you say, touch with building things from the ground up. Kind of just a side effect of working at startups, I guess. So today I want to talk about where Node.js kind of is a good fit in a polyglot architecture. So, why talk about this at all and why now? So a survey conducted by O'Reilly in 2018 basically asked a lot of software architects if they were using microservices, and half of them, or actually a little bit more than half, said yes, like they were actually using microservices. And as of last year, 73% of developers now know JavaScript, which is actually like a 13% increase from the year before, according to the HackerRank Developer Skills Report. And like this community is just growing really fast, and of course the adoption of microservices is also growing really fast. So yeah, like 1+1 = 2, put these together, it's bound to be that some services in your microservices environment will be using Node.JS, which came out in 2009, and it essentially enabled, as I'm sure you're all aware, to use JavaScript on the server side, which was really cool. And then 2 years later, actually in 2011, was the first time microservices, the actual term, was used in an event in Venice. But I didn't want to use microservices in the title itself, because like polyglot architecture, basically is trying to say that you don't have to completely stick to the constraints of an actual microservices paradigm. Like essentially, as long as you have services in your backend which run on more than one language, this talk will basically kind of walk you through where Node.js fits in there. But in these environments, of course, it's kind of difficult to always manage them. And if you're a small organization, sometimes you don't want to take on that overhead. But Google open source Kubernetes in 2015, which like really changed this, because suddenly you had a system where, after the initial setup, it kind of manages these otherwise, which were called headaches in a microservices architecture, communicating between different services, making sure they're up, scaling them out. And Kubernetes kind of does these things like automatically for you, and you can roll out or automatically roll back your application. And so essentially, like smaller and smaller teams could take the advantages that this architecture provides from an earlier stage. And in fact, in 2016, not even the top 20 languages made 80% of all the code online. And this basically is telling us that more and more engineers almost always know more than one language. They definitely prefer to use the language of choice for whatever the problem they're solving. They don't like to be constrained by their environment. And because of all this, I thought, like, where does Node.js fit into this picture? Of course, it provides a lot of benefits, but I don't actually have time to talk about all of them. So I just want to focus on two particular ones, which is kind of like the main things that will affect how we see them in this architecture. The first one is non-blocking I/O, and the second is it being JSON native, or treating JSON basically as a first-class citizen. Of course, this isn't a node-specific feature; it's just a side effect of being able to use JavaScript as a server-side language. So we're going to dive deeper into this, and in this like sort of example architecture I've set up is just like a dummy, but it sort of is like in parallel with how a real one would be. So you have your clients, your web client, web mobile client, desktop, and on the server side, let's say you have 4 different microservices here, like quite trivial, and they're all connected to their own data store. And you have your users making requests, and let's say one of these operations that they're trying to do requires your clients, whichever it may be, to communicate with more than one microservice on the server side. And like you can just imagine the way it would work is like you make one request to service 1, you get the response, then you make another one, and you get that response, and then you put them together, and finally you can render the UI. So this is, as you like, this direct client to microservice communication, is not very performant or efficient, especially if you're using a mobile network. And it also means like your client needs to be aware of the different API contracts each of these services have. So if the underlying service changes, then so you also have to refactor your client. Um, and this is not ideal, right? So in this architecture, usually like you have a gateway layer that kind of solves this problem for you. And Node.js is actually a really good contender in this space to act as your gateway layer, because what it allows you to do is now the client can talk to this layer instead of the services um, which lie underneath it. And there's only one contract to adhere to for the client now. So, and the gateway layer takes control of the responsibilities of talking to, whatever services it has to basically deliver the result to the client. But Node.js's non-blocking I/O or asynchronous I/O basically means that you can do this in a way such that um, you don't have to wait until the operation completes uh, for it to accept other connections. Like Node.js can receive this request and then let's say call service one and then basically queue that event in its event loop, and then move on to receiving other requests from your users, whichever client they may be using. And as you can imagine, this scales really well because suddenly you no longer need to keep your clients waiting until the operation completes. Sorry, you don't need to keep your gateway layer waiting until your operation completes. It's free to accept more requests. And then once it does have the result, it can relay it back to the client. An additional benefit of having this layer actually, and this one's not really node specific, but it will be within your VPC. So if you're in your cloud environment and any network call, especially if you're, let's say, using Google Cloud, their Jupyter network is like extremely fast. It's actually a gigabit bidirectional bandwidth. Um, what that means is it almost as if you have all your services running on the same machine. It's so fast. Whereas if your client was doing this, that would mean that it lives outside your VPC, and every network call you made obviously adds some overhead to the process itself. And some really well-known companies that take advantage of this feature of having Node.js in the gateway layer are like Uber and Netflix. And you don't need me to tell you, they obviously have millions of users using their product, and this ability to scale and efficiently complete their user requests is really important to them. So the question I guess you can ask yourself is like, does our client need to communicate with more than one backend service, and does it need to do this often? In which case, if this is so, like, Node.js is definitely is a contender of to be like the environment of choice to build an intermediate layer. All right. So yeah, so let's say now we have this, and we've added our gateway there, and our application keeps growing. And at some point, it may so happen that you need to provide some real-time services, such as notifications or a chat messaging service, or you're handling some kind of streaming data. And this is another great advantage that Node provides because of its non-blocking I/O. Similar to how it can, keep its thread open so as to basically accept more requests, more concurrent requests. It can also do the same while trying to hold the persistent connection that you need to deliver real-time services with the client. And the difference, if you had done this in a different language, is basically that it does it on a single thread. So, the essential fact here is that Node.js's single-threaded event loop is what makes these like really cool, extremely efficient processes possible. In these other languages, you would be using multiple threads to do the same thing, and what that ultimately means is that you're using more compute resources. Um, and on the cloud, obviously, as you scale, if you have thousands and millions, the more compute you use, the more expensive it will be for you. And having these services in Node means that you can use lower compute resources and essentially save quite a bit of money. And in this case, the question to ask yourself is really quite straightforward. Like, does the service need to operate in real time? Then, immediately Node is a good contender in this regard. And finally, I guess you're probably asking yourself, okay, but I don't have a microservices architecture, right? We have a monolith. How does this make sense? So actually, so do we. We run a DK app and a UK app, and they run on our Kubernetes cluster separately. And of course, they have their individual workers as well. But to give you some more context on, what does it actually take to automate payroll? Of course, it means that we calculate your taxes, your pension, your benefits, but also take it a step further. So like Pento wants to do it end to end in a way such that like we automate your payments, we send the pay slips to your employees, we report to HMRC, we report to your pension providers so that you stay compliant, and also sync with your accounting software, which is all really cool, but it's like a lot of integrations. And as a SaaS provider, you anyway have to integrate with some basic ones like Stripe to, as an example, to provide billing, or you want to have two-factor authentication, so Twilio. But in Pento's case, we have all of this as well. And this, what you see here is just the UK. Like there's an equivalent of each of these for DK as well. By DK, by the way, I mean Denmark. So yeah, this just got me thinking, like, there's so many of these integrations, all with a different set of APIs, and Node.js is JSON native. So that means it treats JSON as a first-class citizen, making it much easier to manipulate JSON data compared to most other languages, especially if they're deeply nested. But this doesn't always apply, right? So like, yes, it is true that Node.js in general is better to manipulate and communicate with APIs. It's kind of sort of what it does best. But for us, these integrations are extremely closely connected to our core product. And we can't really afford any mishaps here, especially not runtime errors, because that would mean, people won't get paid, or, we were, the company reports their taxes too late. So it's just like really not something we can afford. However, since joining the company, I've actually worked on quite a few services which are ad hoc to our main application. And these things included things that basically help us save time all around for our customers and for our operations team. So it includes things like importing of large companies, notifying our ops team so that if any critical error does take place in real time, then we can react to it as fast as possible. And one more service, which was actually the one that I was writing in Go, and I realized that it may not have been the best choice. So it was actually this mistake that kind of led to this talk, where it's not always true just because we use all our other services in a certain language. Whatever your domain or product might be, that it's the best choice for your new product or new service that you're trying to do. And the service I'm talking about is called KYB. And what that is if you're aware with your bank, as an individual, you have to provide your KYC, or it's called Know Your Customer. And it's their way of identifying whether, basically identifying you, and whether it's okay for them to take you on as their customer. And so this is just like the business equivalent of that. And it's called Know Your Business, hence KYB. And this service in itself, if you weren't to automate it, the way it would work is, we would have to ask our customers all the information about their business, their directors and beneficial owners, collect their documents, and then submit it to the payment provider that you use. And of course, we want to do better. We want to automate this as much as possible. So a way, if you can imagine, is like your admin on your product would trigger this API, and in turn you would contact company's house, which is a body in the UK which has all the registered lists of companies in the UK, and has almost always enough information to get the things we need to submit to our payment provider. So we retrieve this, and then we would build a form in the cases where we don't have enough information still, or we want the customer to verify it. And then after building that form, we would send it to the customer, and then once they submit it, we would have an endpoint that listens on this, and then uploads that to Modular, who's our payment provider. And from there, they would take on everything else to verify them based on the information that we submitted. And while all this is happening, of course, we want to also keep an eye on things in our Slack channels, which we use to communicate primarily. And the easiest way to kind of do that is through Zapier. So as you can see, this relatively small service in itself has 5 integrations. And I started writing this in Go, and the further I went, I suddenly realized, maybe it wasn't the best approach in hindsight. Node.js actually even has some SDKs for Typeform and Zapier, so it would have definitely increased or rather decreased the amount of time in which I could have delivered the service. And it's sort of some of the things you can think about when you're trying to develop a new service, whether you already have a microservices architecture or you're using a monolith. Does your service need to communicate with several third-party APIs? Then immediately Node should be one of the contenders, depending on how loosely or closely coupled it is with your main product. So yeah, where this kind of leaves us is, this sort of dummy environment where you can see, depending on your architecture, there are some common things where Node.js fits in quite well. The first being that gateway layer, basically allowing you to handle a lot of concurrent connections compared to other languages, and of course real time, and both of these for that same reason of having non-blocking IO. And finally, integrations. If you have these small ad hoc services or even large ones, depending on how many or who they talk to, you may already have a library built in npm, which is Node's package manager. So that would inherently decrease the time it would take you to build it. Or even if it doesn't, just the ease of manipulation you have to use JSON data in JavaScript really helps. But there are also some cases where it's not so good, whether you're trying. So actually, we're trying to build an analytics service right now, and there Node.js doesn't really, or not just Node.js, but JavaScript in general, doesn't fit out of the box. Though of course, you can make a language things, make it do things that it's not necessarily designed to, but like out of the box, doing compute intensive processes which block the single threaded design of Node.js, kind of defeats the purpose. So it's not the best choice. And for that same reason, if you have a service which is reading or writing to disk a lot, it's not great, because even though Node.js actually says it's a feature that, now you can use JavaScript to access your disk on your machine, those libraries actually have a lot of calls or methods in their API that cannot be done async. So the moment you use them, you're blocking your thread, and you can't do anything else until those operations complete. So that kind of gives you like a picture of like, if you're using microservices, where kind of, or just like an architecture in general that uses more than one language, which is quite common nowadays, and where kind of Node.js would, help you plug in all the pieces together, or where a new service, would really benefit from being written in Node. But needless to say, like, these are in no way exhaustive, and every domain and use case are different. Yeah, I can never have a definitive set of rules that will always fit. But the idea, or the ultimate goal is, as an organization, how quickly can you iterate reliably and move as fast as possible? And sometimes, you know, uh, Node.js helps you do just that. And I hope that the questions we came up with help you identify those places. And if you want to do some more reading on these, like, I've put all the links here. These are some great blogs from all the big companies, Uber, LinkedIn, Netflix, and how they really make the most of Node.js. And the last one, Deno, is actually just really cool, because Ryan Dahl, who created Node, actually has been working on this new project called Deno, which looks to address some of the lackings of Node. And it's just a really interesting read. I encourage you to check it out. And finally, with that, I just want to say thank you. Given the current economic climate, I thought it was important for me to say that we're hiring at Pento. We have a great team, really dedicated, and most importantly, a great culture. Our founders, Emil and Jonas, set it up a few years ago and started remote working, way before it was cool, way before Corona. So they know how to do it really well. And if you're looking for a new adventure, I can't recommend this enough. And in fact, if your company is looking to automate payroll, then also check this out. With that, I just want to say thank you again. And my contact details are here if you want to get in touch. And thanks for having me. Back to you, Tom.
Thanks, Iman. That was brilliant. Just to confirm as well, everyone, we'll be sending out the slide details with a follow-up email likely tomorrow. So all those references you'll be able to look at. Also as well, any questions at all for Iman off the back of that, feel free to use the Q&A function as mentioned earlier, just at the bottom of your screen. But apart from that, without further ado, I'll hand over to Dani. Thanks again, Iman. Dani, do you want to take it away?
So thank you very much indeed, Iman. Thanks a lot, man. Great presentation. And actually, you spoke about Node.js, and I'm going to follow up on that, because the API I have prepared for today's presentation is based on Node. So the theory you explained today to our audience, they will see it working with real code, right? So hopefully both are complementary. Thank you very much to JavaScript Exchange and the organizers for having me today. It's an honor and an absolute pleasure that I'm here with you today, speaking from Madrid. And before starting, I just want to mention and tell you to all the audience and the organizers and the panelists that I hope that you guys are in good health and good shape with this situation with the COVID. I know it's hitting hard, but I hope that you guys are doing well, okay? Good health, good shape, and that we are creating amazing stuff with code, okay? So I'm gonna share my screen, and I'm gonna, you know, guys, that I have 20 minutes today, so it's 7 o'clock in Madrid, 6 o'clock in London. So I will try to do my best to be right on time. Can you see my screen, guys?
Yep, all good, Dani.
Thank you very much. So I'm going to start presenting. So there you go. Today I'm going to create and show you how to create these exoplanets visualization in Threejs that I will show you in a second, how it looks and what it is. So my name is Dani Vicario. And I'm a certified technical trainer and an Adobe Web specialist working as a senior engineer at Busuu. It's a company where we develop course languages to the highest standards. And although I work there today, I'm going to be speaking about, not about languages, but about astronomy. So hopefully you like the presentation I have prepared today. In this presentation, I am including a presentation that, by the way, then later on through the organizers you will receive. I'm giving you a link where you can leave the feedback that you want. Hopefully you like this presentation and you feel after it as much passion as I feel for astronomy and data analysis and data visualization and 3D. And this is something that I wanted to mention as well. So here is the code. Every time I give a presentation, a workshop, a seminar, I speak in a conference, I always give away my code. I have received so much from the society and the community, and I want to give back for sure, okay? So I believe in karma, and I believe that everything I have received from society, well, it's amazing if I can give something back in exchange, okay? So here's all the code of everything I'm gonna be talking about today. And so speaking about astronomy, before I show you this, what is an exoplanet actually, I want to show you what we are going to be building, okay? So is this. So what you see in here is a fantasy texture exoplanet, which actually is real. So an exoplanet, for those of you that don't know what is I know what a planet is, but I don't know what an exoplanet is. So an exoplanet is one planet that is outside of the solar system that has been detected using really sophisticated astronomical instruments and devices. And NASA is really kind, offering all that information to us through really nice APIs. So Iman before was talking about APIs. So actually I'm going to create my own API using Node.JS, and I'm going to consume NASA's API. So from my front end, I'm going to be consuming my own API, and my own API will be serving me one slice of the whole data that I'm receiving from the NASA servers, right? And this name you see here, HT, blah, 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 and this number, they look very strange, but actually this is a real name from a real exoplanet, which actually is the biggest exoplanet that we have detected so far, which is 6.9 times bigger than Jupiter. So that means that it's massive. So, you know, imagine like a small star, you know, it's super massive. But also, I don't want to show you this. I want to show you this, which is a navigation through the 10 biggest exoplanets. And all these textures you see here, I made them by code. So I love a HTML5 canvas, and I want to show you how you can make these. So I can zoom in. I can pan around. The stars are generated by code as well. See? So all these textures, this is what I plan to build. Real names again, real data from NASA. We are really, I hope, hopefully really cool for you, because this is real information from astronomical devices, you know, and in the browser, working with open standards, which is something that never stops amazing me, you know. It's incredible that we can do this for free with open source tools, and that's why I'm giving you my code away. So what is a transit? How do you detect one planet that is so far away? Actually, you know, really far away. So outside of the solar system, there is this way. When you are outside of the solar system, there is this way called the transit detection mode, which is this, right? This super short video, 25 seconds, right? So this is a star, and this is a planet. It is so far away we cannot see it, but we can measure the brightness of that star over time. So say you orientate a telescope towards one star that we know, and it's fixed. It's always looking at that star. And then what you do is you measuring the brightness over time, right? So what happens that we cannot see this planet, but we know we can, because we can see that because this planet is now in front of the star, we can detect a decrease here in the perceived brightness from the Earth, right? And when the planet goes away, orbiting back behind the sun, we can see an increase in brightness, right? So that's the transit detection mode, which is awesome, right? You think about it, it's incredible that by looking in a fixed manner to one star, we can detect over time brightness variations, and therefore we can see that something is there, you know, blocking the light, right? It's awesome. So the next slide in my presentation is the last one, because we have only 20 minutes. And in this presentation, I am including you this link. And by using this link, you come here to the NASA. This is the exoplanet archive. And I simply downloaded the JSON format in JSON format, which is something that, by the way, Iman was mentioning before, this JSON format, which is native to JavaScript. This is JavaScript objects in a native format that JavaScript understands right away without any type of intermediate parser or any intermediate tool. So this row, these are the all confirmed planets, which is incredible, right? I'm going to show you in my source code where I have this JSON. So I have these planets.json here. Oh, sorry, the JSON here. Sorry. So this is it, right? This is the document I downloaded. So you basically have to click here, and that is the document I'm showing you here. So incredibly enough, see, 4,202. So we are kind of stuck with Pluto, Jupiter, the Earth, Mars, blah, 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 right? But actually, there are 4,000 already detected, which is incredible, right? And by the way, many of these planets are detected also using artificial intelligence, machine learning, and these things, right? So here we have lots of data. Let me show you only one. So I'm going to get this one, just one row. I'm going to open here the console, and I'm going to create, increase the font size so you can see it better. Here, if I say let planet equals this thingy, okay, and now I clean and I do planet. Now you can see all the properties having parts by the browser, right? So you have things like the name, the planet host name. Sorry, so this is not actually the name. This is the name of the star is orbiting around. But the planet name is this field. So it's HAT P70B. Okay, so it has two fields that I am interested about. So the two are PL name. PL name stands for planet name, as I mentioned before, and there is another one called PLRADJ, which is the radius of this planet compared to Jupiter, right? So basically, this means that HAT P70B is almost twice the size of Jupiter. So as I said, massive, okay? So given that I have this list, so what I created was an API based on Node.js, which I have around 5 minutes or so to show you real quick. So I created this server which lives in the Express server folder. See, it's super easy. This is Node.js code. And I'm going to show you very, very briefly what I did here. So I am creating Express server. This Express server, what it does is listens on port 4000. So you can see here this JSON, and this is the port 4000. And I'm exposing these planets over by this endpoint called planets. So when I say here, Ably get planets, what I'm doing is here I'm loading all the 4,202 exoplanets. I am mapping them to so I get rid of all the mess, because they are giving you around 80 fields per planet. Some of them are null because they don't know the data. Anyway, so I am transforming these planets, all the information I receive from my hard disk, because I previously downloaded this JSON file with the 4,000 planets, to this new format, which is the planets mapped to another structure with name and size. And then what I'm doing is I'm filtering out those that are null. And then what I'm doing as well is I'm sorting them by size. So that way I get the planet sorted, from the biggest to the smallest. I know you are seeing only 10, but it's because I am saying here, show me 10. If I wanted to show you 50, I save here, and now you see 50. See, but they are all sorted. They are all sorted by size. It's cool that you can sort this in JavaScript, right? If I wanted to sort them in the reverse order, I will do 1 and -1 here. And now you guys have the planet sorted by radius compared to Jupiter, but in reverse order, right? So this data you see here, it can be consumed by my front end. And that front end is the part of code that shows you the planet in 3D, okay? So yeah, cool, super simple code that exposes the information in a nice way here. Here in this filtering, I could do anything you guys wanted. For example, you say, Dani, I want to see the planets filtered by a star, 1 star I'm gonna tell you, or I want to just filter by some of them that have a radius in one way or another. I will do, I don't know, index. So I filter by having 50, and then here I will filter. So I will do size bigger than, I don't know, 5 or 6 to see which planets are bigger than 6, right? Compare the 6. And it's only this one, which is massive, right? And if I did 5, it's even, quite unusual, right? I think the next one is 3. So let's do 2.8. And let's see. Here we have only one planet more. See, so this is one of the operations that have been very, very simplified in ES6, which is called map, filter, reduce. So by mapping, filter, and reducing, I am actually transforming the data from the NASA to another format I want, having only name and size. Filtering, so that means that I don't want this part. It's a subset of everything you give me. Okay, I don't want nodes. And then I'm filtering again by size. So that's really cool. I'm going to return to the previous code I had, and I'm going to show you 10 planets only. So again, I have 10 planets. I'm going to reverse the order back again, and there you go. Now we have the planets being served with real data coming from the NASA, right? So next step is showing you how I generated these random textures, right? So here in the public folder, I created these, right? So these generated textures, I made them by code, right? They are made with HTML5 canvas, and I want to show you in a couple of minutes how I made them, right? I made them. So here, this code is only a support code for, as I said, right? A support code for the planets. So because with this, I generate the textures. Let me show you, right? I have some basic textures here. And then what I do is, by using this code I have here, what I do is, real quick, I load a couple of them randomly. I load one, I load another. And then what I do is, like in Photoshop, you in HTML5 canvas can change the composition modes of the layers. So that means the way I expose the pixels, right? And then, so I'm loading one texture and another texture. It's one of these textures, and randomly say it chooses this one and this one. And then it tries to mix them up. And it's doing it by exposing the pixels in an overlay mode. Then I change the color by code. Then I apply some blurring and a little bit more. And then I use this library called reimage that what it does is allows me to download in PNG format. So let me show you how it looks. So I come here and it's texture generator. The folder is called, texture generator, and then is the index HTML. And so the texture generator, what it does is it produces, see, it's producing now, I don't know, you can see it here, it says image 9, image 40, image 41, see, so it's getting random images and combining them in HTML5 canvas, and with reimage library, with the reimage library, what I'm doing is I am saving them to my hard disk. See? So these are randomly produced textures. Let me show you how they look. I'm going to stop it because otherwise it's going to continue. So I could leave this process all night long, and then when I wake up in the morning, I have 1 million textures of planets. So these are some of the textures I have just generated. See? They are made with HTML5 canvas, combining two pre-existing textures, rotating them, change the hue and saturation, and so on. Right? Cool. So here you have the textures, and I move them into this folder. So these are the pre-existing textures, and these are the generated textures by code. So I made 28 only, these ones, and they are in the repo that I'm sharing with you guys, so you can enjoy making your own planets. So next is, and I am 5 minutes to finish, way to finish. So now you have the random textures, and I have my front end, right? I'm going to show you now the 3D part. So it starts with this index JavaScript, the index.js. And as you can see here, I'm using the new module system that I can use these imports because I am using this Babel, which is specified in the package.json as a dependency, right? By the way, here, if you enter in the Planetarium project, which is what I'm going to be sharing with you, you guys here have all the instructions about how to install the dependencies, run the server, the API, and the front end, right? So here I'm consuming my API, the 10 planets I showed you before, and then I'm sending them to my planet constructor. Here, the planet constructor, what it does is initializes the scene, which actually sets up the 3D and then creates the random star field that I showed you. Let me show you back again. So it's localhost 3000. And see, look at this detail. So I reload. See, it fades in. You have to take care, guys, about the small details. See, fade in. And also the typography, I tried to find a typography that was kind of, for sci-fi. You cannot use Arial here, right? Like, right? And then, so I am listening to the keyboard, and when I press G or H, I'm moving to the next planet or the previous planet, okay? As I said, you can zoom in, you can zoom out, you can pan around, right? You can see the stars here, and I can go very far away, see, and you can see the planet. This imaginary planet with this random texture producing HTML5 canvas. So I'm going to show you the planet class, and with that I finish because we don't have more time. And then you can, for sure, you can check all this code when I give it to you. And please don't hesitate in coming back to me through LinkedIn, through my Twitter, anything you want, guys. I am at your disposal because, helping others is something that I really makes me feel amazing. So the planet class, what it does is here I create random textures. So I create, because I have 28 random textures, I sort them in random ways. So I create different numbers. That way, every time you reload this, it's a different texture. See, always different. And so it's loading them from this generated textures folder randomly in random order. So here I calculate the minimum size and the maximum size of the planets in this list of 10. So the maximum is this number, the minimum is this number. And then what I do is I create a scale. So actually what you see here, it's the planet with its real scale. That's why the next planet is half the size, see? So this is 3 coming from NASA, 3, GT loop B. And then this planet is massive, this planet is smaller, and these other ones are smaller and smaller and smaller. So here this code makes it possible for you to have a real scale, so you guys can see how the biggest planet compared to the smallest planet of the data set that I created, they will look actually, right? Amazing. And here I load the texture, I load a random texture that I calculate here. I calculate a random number. So say I calculate number 5, so I will take image 5, load it into this variable, and then load as a material. If I didn't load this as a material, you will see an empty sphere rotating, right? And then here is when I modify by code this. See? So if I wanted to tell you hello guys as well, I would say hello guys. And then I reload here, and now the planet says the number and hello guys, see? And so here's where I'm modifying based on what I received from the API. And so every time I'm changing the planet, I always remove the planet, and then I always, make the fade in effect. And here's when I move back and forth, right? And in 2 minutes more, I wanted to show you how the scene is set up, and then I'm finishing. I'm open to questions. So this code is Threejs. Threejs is an amazing library for 3D manipulation. So what it does is I can have orbit controls. It's based on WebGL, so it's super optimized and works almost like in C++ performance, 60 frames per second in the browser. So it's absolutely awesome. You can create games and like planet exploration like this, because, well, think about it. I could do this. I can go to enter full screen, and you can have this in a monitor, in a projector in your home. You could have a random planet every day. So every time you come home, every day when you come home, you have a random planet being shown here with the latest discovery from the NASA or something, right? So you always want to do some creativity, right, with code here, and you can do amazing stuff. And just to finish, I'm going to show you here how the planet is rotating. So you have the star field. You have the lights, and you have the play function. And the play function is moving the mesh in the Y. So the Y is the axis, by going across the planet. So if I did this, 55, this will be super fast. See? Now it moves way faster because I am rotating it over the Y axis. And now you can make it on the Z and on the X, and you will see it rotating in all directions, right? Like crazy. See? See? So as I said, I know it's a lot of code, but I wanted to give you something viable, guys, something that you can experiment with and something that makes you feel passion. In my case, it's astronomy and data analysis. I hope we can keep in touch. You have my contact. And as I said, if you have any questions about this code, or you want to extend this project much farther and create something cool, you don't know how to start, I am available to help you and to answer any questions. Once again, to the organizers and to all of you folks, thank you very much indeed. I'm really, really happy to be here with you, and greetings from Madrid.
Thank you, Dani. That was really, really interesting stuff. Just to reiterate, guys, again, obviously the Q&A function is down the bottom there. And also this recording is, this talk is being recorded as well. So we'll be releasing that tomorrow for everyone to look and obviously track your code, Dani, as well, which I'm sure will be helpful. But yeah, without further ado as well, I think last but not least, Srushtika from Ably, would you like to take over?
Sure, thank you, Tom. Just to check, can you hear me? The most standard question these days.
Yeah, yes, we can all hear you, no problem.
Okay, perfect. So I'm gonna quickly share my screen. All right, there you go. Cool, awesome. So I'm Srushtika Neelakantam, and I work as a developer advocate for a company called Ably Realtime. For those of you who haven't heard of Ably, it offers a pub/sub messaging infrastructure as a service, so you can use it to build any sort of real-time or live sort of applications, like chat or location tracking or multiplayer games, right? So at Ably, a couple of months ago, we hired my new boss, Ben Gamble, who's the head of DevRel, is really passionate about games. And every day, because now we're working in a remote sort of scenario, we have these daily stand-up calls, and in every call, he would just talk on and on about how he loved building this game in his free time, or this game he played, and all this interesting stuff that is happening in the game world. And I, on the other hand, had never really played any games, and let alone building any games, right? So just to understand at least the jargon of whatever was happening in that game dev world that was getting Ben so excited, I thought, why not build a game myself, also a multiplayer one, because hey, I work for Ably, I'm a dev advocate, so I should be able to, put some pub/sub stuff together and have these things communicate with each other, right? I thought it's just gonna, be an evening project and it should be okay. I mean, not an evening one, just for a day, but you know how it is. Guess what? I was wrong. It's not as easy as it sounds, because it's not just in games. It's not just the point of getting all of these different entities to talk to each other, but it is absolutely necessary to do that in the most efficient way possible. That is because if you think about it, games are nothing but, continuous loops running all through the duration of the game, in which all of the game objects that are present on your screen are basically discretely being moved from one place to the other as part of that loop. So in a sense, if you think of a kite that needs to move from, say, a bottom position to the top position, in that continuously high frequency game loop, continuously running high frequency game loop, you would take that kite and say, hey, just append the Y position of it by 0.2 points or something. And then because it's running so fast, it will basically look like it's a moving kite that is just flying through the air. It'll look continuous, like a video game, but as you know, it's not. And this whole game loop thing is not just on this object, but if you think about this game loop being applied to every other object that's present on the screen, you can start to think how complex it makes everything. And as if this is not complex enough, I thought of introducing this concept of, updates being received from the network, making it multiplayer so other people can collaborate on the same game. So you're taking this high frequency loop, getting data from the network, and then updating all of these things. So I was like, okay, I can't do this. This is just out of this. But thankfully, again, Ben showed me that there are, predefined design patterns and, different architectures in which you can make, most efficient architectures out of this sort of communication strategy and build a multiplayer game, because obviously these kind of games already exist and people are doing them in production. So I then thought of making, okay, my slides are moving. Okay. So I then thought of building, taking the classic game of Space Invaders and making a multiplayer version of it using Phaser 3 and Ably. So in this talk, I'll show you how I built this game and what are the different caveats to, building your own multiplayer game. I'll quickly talk about, the rendering and moving all of these objects in your game area. But I'll largely focus on the networking part of it, different strategies in which these different entities can communicate with each other in order to make sure, the game is still in sync for all the players and they can just, collaborate live. And you can also make this game production level directly scalable, whatever you want, like a real game of Call of Duty or something. See, I know a bunch of game names now. So before we go on to, all of the things that are behind this game, you need more context to understand whatever I've been talking about from the beginning of my talk. So what better than to actually play a live game now, live. I'll just share a link and we can all play this together. I hope you'll join. So I'm just going to quickly share the link of the game in the chat box. If you're on a computer, you can visit that link. What I'll do, Okay, one other thing I forgot to mention is that I will, as a bonus at the end of the talk, I will also talk about Node.js worker threads, which was released as a stable version only recently earlier this year. I'll tell you how I used Node.js worker threads to create sort of game rooms. So simultaneous game rooms can be running on a single Node.js server. So I'll tell you all about that. If you can go visit that, I'll create a room and share a code that you can use to join. So I have my room link there, and beware, I have not added sound as optional. So if you have headphones on full volume, please be aware of that. So this is the room code that you can enter in the join tab. Because I'm the host of the game, it gives me a button to actually start the game when enough people have joined. And yes, there you go, people are joining. And you can use your left and right arrow keys to move left and right for now until I start the game. But even when I start the game, you can just move left or right according to where you want to be. When I start the game, there will be a shooter shooting bullets. And the idea is to make it to the end of basically the bottom platform without getting killed. All right, so let's see how this goes. And as you can see, this is sort of like an flipped version of the actual Space Invaders, because we're the invaders in this case, not actually the shooter. So I'm gonna wait a couple of more seconds to see if other people are joining, and then we'll start the game. Okay, cool. So let's go for it. So I'm gonna start the game. Be aware, the shooter is just gonna start shooting bullets. So be ready, and I'm starting the game. People are already getting killed. For the person who built this game, I'm actually not great at this. So I always get killed. Let's see, we have 2 people left. I already died. Let's see if, oh, there you go. Someone's dodging really, really nicely. And the shooter is basically randomly changing directions and speed. So you have no predictability into that. Almost there. Come on, whoever this is. There you go. Okay, P, you could have chosen a better nickname, so we knew you won, but whoever P is, you won the game. Congratulations, and Tom, you're second, and Obi, you're the second runner-up. All right, awesome. So I hope you had fun, and I hope you have a bit more context to whatever this multiplayer game thing is that I've been talking about. So let me get back to the presentation and tell you how this is built. Oh, I never actually showed the URL. Never mind. So for any of these, sort of multiplayer games, what I realized was that you can break the whole thing into 3 core components. The first is, of course, the assets. I have, these avatars, you have the audio playing when the bullets are being shot, etc. You need a way to efficiently load these assets from wherever they are, on the internet, on your disk, wherever. You need to keep them ready to show on your game screen whenever you need it, according to your game logic, or remove them or play animations and things like that. So that's one of the aspects. The next one is, how we have physics laws in the real world. If I throw a ball from my rooftop, it'll actually fall down because of the gravity. Similarly, in all of the games, the way different objects work and move around and interact with each other will depend on the physical laws of that game itself. And you need some sort of a physics engine to actually define those laws and make sure that these game assets are adhering to that set of rules. So that's the second core component. And the third one, which is the most important one when it comes to multiplayer games in particular, is the networking. Now, as you saw, we all played the game, and it was completely 100% in sync. There was never a point when I was looking at something else and, another player was looking at something else, because in that case, it would be out of sync. And then I would claim as a person to have been dead. And on the other person's screen, it'll look like that person is still alive. And it's just a whole lot of confusion. So you can't have that in this sort of a multiplayer game. So that is, as I said, that is something I'll majorly focus in this talk. But for the first 2, assets in physics, in this particular game, Space Invaders, I've used a library called Phaser.js, and it is very useful because it straight away solves the 2 out of the 3 problems that I just talked about. It gives you ways to quickly load assets and show them in a game area based on, Canvas on HTML5. It uses the web graphics library to actually render them. But basically, you can use Phaser and tell them, hey, I want this avatar to be rendered at this location when this game logic happens. And it'll just do that for us. And it also has a bunch of physics engines. So we don't have to, calculate mathematics from scratch, define what happens from scratch. You can just tell Phaser, hey, when the bullet and the avatars collide, you can just play the explosion animation and then kill all three asset objects, right? And Phaser will do that for us very easily. That's it. Our job there is done. So let's take a look at a bit more depth into how Phaser actually works. You start off by defining a configuration object. This is basically, how you want your game canvas to be, the size of the canvas, the, styling of the canvas, and which game engine, because Phaser has multiple game engines. You can also define which game engines it needs to use. And also you'll define the list of scenes that you want to play in your game. Because in this game that you just saw, we had just one screen, we had a single scene. So that would be something like this, which is a class. It extends the phaser.scene object, and inside this class, there'll be 3 default methods. The first one is preload. Now this is very handy because what it does is this is where you specify all of the different game assets that you will need at any point in the game. You'll just preload them, keep them ready to go as soon as you need them according to your game logic. Because at the time the game is already playing, if you want to fetch a resource from the network and then show it, it adds up to a lot of lag. And you can't really afford lag in games because it's just a horrible experience, right? So in the preload method, you define all of these assets and you can tell them, hey, I want this asset to be rendered at this point, etc. Then there is the create method. Create method is sort of like an initialization method where you define all of the animations, sounds, initialize a bunch of variables as you need in your game, etc. Now, the third important method, this is the crucial one, is the update method. Now, as I was talking about in the beginning of the session, update method is the one that runs in a loop at super high frequency. And in this method is where you specify any updates that you want to do to your game, like moving the positions of already present objects, adding new objects, removing objects, anything that you want to do. Just in update, you check for a condition and do whatever you need because it runs in a continuous loop. Right, so let me quickly show you how this is in the actual game. So this is a front-end script of the game. It's on GitHub. I'll share the link later. But don't worry about all of this code that you're seeing right now. I'll explain that in a bit. But all you need to know is that there is a game object, configuration object here, which defines all of the different things, as I said, about the canvas. It also lists the different game scenes. Right now, I only have a single scene called the game scene, and this is defined here. Now here I have the preload method, which loads a bunch of sprite sheets from different places on the internet, specifies its dimensions and things like that. Then there is the create method. In create method, as you can see, I'm initializing a bunch of variables. I'm also defining how different animations need to play at what rate and things like that. And then we have the most important one, which is the update method. In this, I'm updating different objects based on whatever is happening according to my game logic, which also I'll explain in just a bit. But this is essentially what you need to know for now. And as you can see here, after this is all mentioned, you can just launch that game by calling new phaser.game and passing the configuration object that we created initially. Awesome. So that's pretty much about the assets and physics part of the game. Now let's get into the fun part, which is networking for the game. Now, when I wanted to make the game multiplayer, when I was building it initially, and I had no idea how to build games, I thought, okay, so really it leaves me with 2 basic strategies. Like if I think of a brute force approach, I could either send a message to everyone who's playing with me in the game. Whenever my position changes, I can just say, hey, my position is now 10. Hey, my position is now 10. And I can do that for every player that is, that needs to know that information. Or I could sort of have like a channel I'll talk more about what channels mean, but just conceptually, you can think of it like a pipe where I've published some data, and all of these other players are just picking that data from that pipe because they're also participants on that pipe. But even so, this gives rise to, you know, two different problems. The first one is the peer-to-peer approach, where every player is publishing their data to every other player, which means for, you know, in a scenario, in a game where you have n players, you have n players communicating with n other players, giving rise to big O of n squared time complexity. And for games which are already so complex and which are already running so many loops and things like that, n squared complexity is just not acceptable, especially in this high speed real-time sort of game scenario. So that was out of the way. And the second thing where, you know, a player publishes data into a channel is, let's say I publish my my position, but all of the updates on my screen are happening so fast that after I publish, my state has already changed. And by the time that other people pick up that data from the pipe, I'm already in a different state. So there is a very high possibility that, you know, all of these players are out of sync and they don't actually see the same game state at any point of time. So the better way to actually implement this is then to implement something popularly known in game dev circles called the client server strategy, where, as you can guess, there is a server, which would be the game server, and the game server would be the central authority to, you know, maintain the global state of the game, the latest state of the game at any point of time. And the players never talk to each other, but talk only via the server, in a sense that all the players just publish their location to the server, and the server just gets all of this latest data and then collects it and, you know, maintains a particular game state object and publishes it back to all of the players. Now, because the server publishes this data, you know, this game state to all the players at the same time, they just use this latest update that they've received from the server to actually render the game, thus making sure all of the players are, you know, synchronized 100% up to the, you know, closest millisecond or so, which is exactly what we need in this sort of a game, right? Now that that's out of the way of, you know, which strategy these different entities will communicate with each other, the next thing is deciding how exactly would this communication be implemented. Now, if you're aware of, you know, different communication protocols like HTTP, WebSockets, and MQTT, I'm not going to delve deeper into those protocols because that's a whole other talk to, you know, just tell you the differences and what's better in which scenarios, etc. I actually have a lot of resources and other recorded talks on YouTube. You can check that out or ask me questions if you're interested to know more. But if you haven't heard of, you know, WebSockets, all you need to know for now in this context is it allows two entities to communicate in a sort of connected fashion. So when you set up a communication channel, the connection remains open for the duration of the app running. This gives both of the entities a way to communicate with each other in both the directions simultaneously. So this is exactly the kind of thing we need, right? We can't actually send a request to get the updated information and then wait for the response to come back and the, you know, HTTP cycle closing because it's all stateless, etc. So WebSockets is stateful, the connection is open, and all of the entities can push the data as soon as they have the latest data to any subscribers there might be. Right? And that's exactly what we've used. Now, to actually implement this sort of WebSocket-based communication, I could either, you know, build a WebSocket server from scratch, but instead I used Ably, which is PubSub architecture or infrastructure as a service, because essentially all I need is not just the WebSocket-based communication, but I need the PubSub sort of publish subscribe messaging pattern on top of that. And I also need some other add-on features like, you know, message ordering, reliability, scalability. If I have, you know, more and more players, because I have, you know, multiple game rooms as well, I just want, you know, hundreds, thousands, or even, you know, millions of people playing together online. And I just want that kind of scale and the right order of messages in the order that they're published into the channels. You could instead use, you know, Socket.io, which is an open source framework. This provides, you know, WebSockets communication and also PubSub on top of that. But obviously, you can't really scale with that, and you won't have a bunch of other add-on features that I've been talking about, like reliability, you know, security, and all of these good things that I need. Awesome. So That's Ably. And in the client server architecture that I was talking about before, Ably will conceptually sit there where the players will now publish their data to Ably, and the server will publish the collated game state to Ably. And they don't have to actually worry about who's on the other end subscribing to that data, because Ably will do the high-speed routing from publishers to the subscribers of data. And conceptually, if you think about it, in most of the real-time applications, there is a concept of channels or topics that I was mentioning before. Essentially, in the whole application, if you think about it, there's a lot of data that is flowing through all the time. But it's not necessary that all of the clients that are involved in the application need to know all of that data. So what you do is you fundamentally break this complete data down into different logical units, and then publish or send them in these different topics or channels. For instance, here, as you can see, there's location channel, which carries location updates, and then job updates channel, which carries job updates. And the customer desktop and the mobile don't have to do anything with the job updates channel. They just need location channel. And on all of these channels, any of the entities which are interested in that data can either be publishers or subscribers, as both, as you need. Now, in our application, in the game application, you can think of one channel that is being used by the server to publish the global game state to all players, and all the players are subscribed to this channel in order to get that update from the server. And then each of the player have their own unique channel where they're publishing their input, which the server is listening to. So if there are 3 players, the server is listening to 3 player channels and then publishing to this other game room based channel for the global state update. I hope that makes sense. And just to give you a bit more understanding of what is actually happening in the data part of this whole thing, Ably has this feature called presence, using which you can track different clients when they get connected, when they enter your game, when they leave your game, etc. So you can just listen to an event called enter on presence on a channel, and then it'll just send a callback saying, hey, this particular client with this unique client ID has entered your game. So whenever a client enters, I'm creating this new player object with all of these attributes, a unique ID, avatar type, color, XY score, nickname, and is alive status of the player. And then what the server is doing is it has an associative array where it is storing all of the players' data as key value objects, just like this. So this object will be there for every player that is part of the game, and the server will just make sure that this array is has the latest data as possible based on the updates it is receiving from all these players, and then it publishes that at high frequency. And by high frequency I mean 10 messages per second to all of the players who are playing, so they have the latest context at any point of time. So that's the new player object. And if you think of the server that's actually publishing the game state update, now players is the associative array that I was talking about, which is made up of the key value pairs, which is one for each player and their attributes, and the player count at any given point. If the front end clients wants to know how many players are there, you can just have that as well. And then the ship body, because the ship is controlled from the server, not on the front end side, it'll also send the position of the ship. Bullet or blank is because bullets are not shot every time there's an update from the server, is just to say for every 20 updates or so from the server, I want to shoot 1 bullet. So that's just a thing for that. And then just to check if the game has already started, and the killer bullet. Now killer bullet ID is important because each bullet, if you think about it, is a different sprite, right? And you need a way to identify these different sprites, because if my avatar is killed by a bullet with ID A, I need to be able to tell other players that kill the sprite that belongs to Srushtika, but also kill the bullet sprite, which actually killed that player. So I need to be able to track that information, and that's what the killer bullet is for. Awesome. So if you now look at the update method, I think this is visible. Tell me if not, but I'll use a pointer just to make things clear. So in the update method, which I showed you before, which is part of the phaser thing, which updates at high frequency, we'll check for all of the different variables in that game update that we receive from the server, and then we render the different game objects according to that logic. So if I quickly run you through it, Avatars is another associative array that's only on the front end side, and this is used to store the actual sprites and the attributes of those sprites. The reason it is only present on the front end only is that because we don't actually need to transport the sprites to all the other players. They can just render them locally, and all you need to do is update the position and other attributes of those avatars, which is anyway present in our game state update that we're getting from the server. So if you see, for every avatar, it basically checks if that avatar, if that player has somehow disappeared from the global list. I'm just going to destroy that sprite and delete it from my local state. This is the front end, by the way, just so you know. And then for every entry in the player's associative array, if you remember, this has a key value pair for every player that is present. There could be a couple of things happening, right? It could be so that I have an avatar on the front end for it, and the player is alive as per the global update. Now, this just means that everything is fine. I just need to update the position of the existing avatar, based on the latest position that I've got. And the next one is if I don't have an avatar on the front end for this player, but the player is alive according to the update from the server, it means new player just joined, which I don't know about. So I just create a new, sprite for that, and then render it on my screen just to show that this player has joined. Now, the third one is if the avatar exists locally, but the server tells me that this player is no longer alive. That means the player just got shot, and I just need to play the explosion, and remove the avatar, the bullet, and just, play the sound and things like that. That's pretty much what this one is doing. And if the game is on, as you saw, after I started the game, that is only when the ship started moving and the bullets started being shot. So if the ship is on, just check whatever the latest position of the ship is from the server update, and then render that accordingly in this method. And there is a method to publish my input, which means I'll have a unique channel for my to be able to publish my input, which is essentially left and right key presses, that will be tracked by the server to update my left and right positions accordingly. And this is true for every other player who's playing the game. They'll have their unique channel identified by their unique client ID, and they can just publish their data. And the server, as I've been mentioning, it'll just collate all of this and then update this game state, the player's object, which is again sent back in game state. So that's how this whole thing is set up. Cool. Now, as I said, as a bonus, I'm just going to click the pointer off. I was talking about Node.js worker threads, right? Now, Node.js released this concept of worker threads, which allows JavaScript to be multi-threaded. Now, this is really cool because now you can run multiple, almost like multiple instances of the same Node.js file in your game. So what I've used this Node.js worker thread is to be able to host different game rooms that can, simultaneously have multiple people in each game room playing the game without any relation or noise from the other room. Now, this is made possible not only with Node.js worker thread, but also with a concept called namespaces in Ably. What it is that, for different channels that are present, Ably allows having channels within different namespaces as well, which means if I have, namespace ABC and PQR, I can follow it by colon and say ABC colon game room channel, 123 colon game room channel, which means these two namespaces have no relation with each other and hence no, access to data from the other room. And I can hence use all of these different namespaces to host different game rooms, and the data is all, separate and it doesn't get mixed up. So to understand how this works, as a host of the game, only the hosts have the capability to actually create a new game room, which they can invite other players to play in, as you saw. So the host of game, say ABC, will tell my main server saying, hey, I'd like to host a game. And because the host has asked that, the server will say, okay, let me create a worker server for you and give you access to it. Now, one thing to note is that the unique game code that I shared was being created in the front end on the host side, which means the host, the main server, and the worker server all have access to this unique game code. And this is the unique game code I'm using to actually make, build namespaces for that particular game room, just to make sure everyone is then part of that game room and everyone knows where to go. Now, after the game server is created, it'll basically on the game specific channel or namespace, it'll come back to the host game and say, hey, by the way, I'm ready to talk. So let's start playing. So now the host can basically detach from the main server because it no longer needs any connection to the main server, and completely play the game with the worker server playing the role of this, the authority, the central authority that maintains the game state. And all of the different players who would now join this game using the room code will directly talk to the worker server for game ABC and will have no relation with the server. Now, of course, Node.js worker threads also allow the workers to be able to talk to the main thread, which means every time a new player is entering or dying or any, that sort of number is varying, my worker server will just communicate to the main server and say, hey, by the way, I'm alive and I have 10 players playing in my game right now. Just so a server has these stats and it can, allow people to enter the same game room, or it can check, if a game room doesn't exist or if the game has already started, and all of those sort of conditions. So the main thread and the worker thread can thus stay in sync and keep talking to each other. After the game is finished, it'll just, kill. The worker server will kill itself and the control will go back to the server. If a new host comes, a new worker thread will be created, and so on. And you can have, multiple hosts starting multiple worker servers at the same time as well, thus giving us the capability of running simultaneous game rooms. If you want to see as if, this is not complex enough, I'm going to show you another super complex architecture, which is this. It's exactly the same thing as that, where there's a host, player, global channel via Ably, talking to the main server, worker one, etc. I'm not going to explain this in too much detail, but it's exactly what I explained in the simpler diagram before. I'll share these slides, so hopefully it will make sense when you look at it after this session, and try to understand what is going on. If you're interested to look at the full code of this project, it's available on GitHub. Space Invaders project. I mean, this is just a shorthand for the actual link. I'll share these links in the chat as well. And I've written a very extensive article series, a 4-part article series, talking everything about rendering of assets, the networking, different strategies, and a lot more caveats than I could cover in this talk. And of course, the step-by-step implementation of this Space Invaders game on dev.to, and that's the link for that, which also I'll share in the chat. Feel free to check them out. If you have any feature requests, feel free to make a PR for the project. And another good thing is that I'm currently working on making generic framework for this sort of a networking architecture to make multiplayer games on the web. So what you can do is, if you want to build a similar game, you can just use that starter kit and just focus on the game part of it and not at all on the networking part of it, because that'll all be built as part of the framework. So keep an eye on my Twitter. I'll be publishing that in the next couple of weeks, and I'll be shouting about that on my Twitter. And hope this was useful and you understood things. If you have any questions, feel free to reach me out anywhere. Thank you very much.
Thanks, Srushtika. That was awesome and really fun as well. It was a good game. Thanks everyone for tuning in. I just want to extend a further thank you to all of our speakers, Dani, Iman, and Srushtika as well. Thanks all for joining. Just a reminder, all the slides should be shared with you tomorrow with a follow-up. And of course, we've recorded this event as well. So all of the code and everything we've ran through will be uploading to YouTube and sending you that link tomorrow as well. So yeah, thanks again, everyone. Next Wednesday, we're partnering up with Coderi for our next event, which is that coding challenge. More details will be sent to everyone tomorrow as well. And apart from that, stay safe and we'll see you soon. Take care.